Hello students, welcome to the first lecture on engineering mathematics. The subject name for the first semester mathematics course is Calculus and Linear Algebra with the subject code 18MAT11. Let us begin with the first chapter or first module, Differential Calculus 1. As the name itself suggests that the first module is completely based on the concept of differentiation. The module begins with the concept successive differentiation. As you are already familiar with differentiation, successive differentiation is nothing but differentiating a function successively to derive its higher order derivatives. That is nothing but, say suppose a function y is equal to f of x is given to you. Find the corresponding derivatives of the function. That means find the corresponding first order, second order and third order derivative of the function and observe the pattern in it. By observing the pattern in those derivatives, in those successive derivatives, you are going to derive the nth order derivative of the given function. So in short, I can say that you are given any function f of x. Try to find the corresponding nth order derivative of the given function by observing the pattern in the successive derivatives. Let me explain with an example over here. Let me just find the nth order derivatives of some standard functions. Let me start with a simple function e to the power ax. In order to get the nth order derivative of the function, let me observe the pattern in the successive derivatives. What is the first order derivative of the function, students? Since your a is constant over here, the differentiation of e to the power ax is nothing but a into e to the power ax, right? And the second order derivative is, just keep a as it is and differentiate your e to the power ax. So the second order derivative will be of the form a square into e to the power ax. What is the third order derivative? The third order derivative is of the form a cube into e to the power ax. So can you guess what will be the nth order derivative? Just observe the powers of a. When you are doing the first order derivative, the power of a was 1, right? Into a to the power ax. And when you are doing the second order derivative, it was a square into e to the power ax. Third order derivative, it is a cube into e to the power ax. So that easily I can say that the nth order derivative of the function is of the form a to the power n into e to the power ax. Okay, hope you got the point over here. Next standard function, students, y is equal to a to the power mx. We'll just analyze the successive derivatives to obtain the nth derivative of the given function. The first order derivative of the function is a to the power mx into log a and then differentiate mx with respect to x, that is nothing but m, right? So I can rewrite the expression as m log a multiplied with a to the power mx. And the corresponding second order derivative of the function is, keep your m log a as it is a constant, and differentiate a to the power mx. What is the differentiation of a to the power mx? It is a to the power mx log a into m, or I can just rewrite the expression as m log a whole to the power 2 multiplied with a to the power mx. Can you analyze the pattern over here? For the first order derivative, the power of m log a is 1 here multiplied with a to the power mx. For the second order derivative, the power of m log a is 2 multiplied with a to the power mx. So that I can easily guess the nth order derivative of the given function is of the form m log a to the power n multiplied with a to the power mx. Okay. last standard function y is equal to cos of ax plus b, where both your a and b are constants. We'll find its successive derivatives. What is the differentiation of cos of ax plus b, students? It is minus sine of ax plus b, and then the differentiation of ax plus b is nothing but a, and the corresponding second order derivative is minus cos of ax plus b multiplied with a square, and the third order derivative is sine of ax plus b into a cube. Can you analyze the pattern over here? The pattern is not uniform, right? The first order is in terms of sine, second order is in terms of cos, whereas the third order is again in terms of sine, and sometimes it takes the derivative is negative and sometimes it is positive, isn't it? So the pattern is not uniform to guess the nth order derivative of the function over here, right? But just make a note of it, students. Since they have asked you to find the nth order derivative of cos of ax plus b, that means they are expecting you to find the nth order derivative of the cosine function. Try to express the successive derivatives in terms of cos itself. Can I write minus of sine of ax plus b as cos of pi by 2 plus ax plus b? I can, isn't it? Because you know that cos of pi by 2 plus theta is minus sine theta, right? So I can write minus sine of ax plus b as cos of pi by 2 plus ax plus b multiplied with a constant a over here. Similarly, I can write the second order derivative over here as a square into cos of 2 pi by 2 plus ax plus b. What is cos of pi plus theta, students? Cos of pi plus theta is minus cos theta, right? So I can write minus cos of ax plus b as cos of pi. 2 pi by 2 is nothing but pi over here, right? 2 pi by 2 plus ax plus b. Similarly, I can write the third order derivative, that is sine of ax plus b as cos of 3 pi by 2 plus ax plus b. Okay, because we know that cos of 3 pi by 2 plus theta is sine theta, right? So I can write sine of ax plus b as cos of 3 pi by 2 plus ax plus b multiplied with the constant a cube. Now, can you analyze the pattern? The first order derivative, what is the power of a here? The power of the constant is 1 multiplied with cos of pi by 2 plus ax plus b. The second order derivative, it is a square into cos of 2 pi by 2 plus ax plus b. Third derivative, a cube into cos of 3 pi by 2 plus ax plus b. So I can easily guess that the corresponding nth derivative of the function is a to the power n into cos of n pi by 2 plus ax plus b. Hope you got it. Here are the list of the nth derivatives of the standard function, students. However, the derivation of the nth derivatives of standard functions is not included in the syllabus. But to know how to obtain the nth derivatives of the function, I have explained with some examples. So it's enough if you just remember the nth derivatives of these 9 standard functions. No need of the derivation. It's enough if you just remember the formulas. That is, nth derivative of e to the power ax is a to the power n into e to the power ax, and nth derivative of a to the power mx, where your m is a constant over here, is m log a to the power n multiplied with a to the power mx. Say suppose some algebraic function is given to you with the power m, which is of the form ax plus b to the power m. Then its corresponding nth derivative is m into m minus 1 into m minus 2, so on up to m minus of n minus 1, that is nothing but m minus n plus 1 multiplied with ax plus b to the power m minus n and a to the power n. Just be careful with the powers over here, students. The power of a is n over here, and that of ax plus b is m minus n. And the nth derivative of sine of ax plus b is a to the power n into sine of ax plus b plus n pi by 2. And that of cos of ax plus b, I have already explained it. That is a to the power n into cos of ax plus b plus n pi by 2. The nth derivative of the product of the two functions, that is e to the power ax into sine bx plus c, where your a, b and c are constants over here, is given by a square plus b square to the power n by 2, or you can also write it as square root of a square plus b square to the power n multiplied with e to the power ax into sine of bx plus c plus n times tan inverse of b by a. And that of cos of bx plus c into e to the power ax is a square plus b square to the power n by 2 multiplied with e to the power ax into cos of bx plus c plus n times tan inverse of b by a. The nth derivative of 1 by ax plus b is minus 1 to the power n multiplied with n factorial and a to the power n divided by ax plus b to the power n plus 1. And that of the nth derivative of log of ax plus b is equal to minus 1 to the power n minus 1 multiplied with n minus 1 factorial into a to the power n divided by ax plus b to the power n. There is a slight difference between the nth derivative of 1 by ax plus b and that of log of ax plus b. Just make a note of it. As you are familiar with the nth order derivatives of the standard functions, we will now find the nth derivatives of the product of the two functions, which is introduced by the mathematician Leibniz. So the next concept is Leibniz rule for nth derivative of the product of the two functions. The formula is given by the nth derivative of the product of the two functions u and v is given by nc0 u into nth derivative of v plus nc1 u1, that is nothing but the first derivative of u multiplied with n minus 1th derivative of v plus nc2 second derivative of u multiplied with n minus 2th derivative of v, so on, so that the last term of the equation is ncn into un, nth derivative of u multiplied with v. Let me just simplify the above equation. NC0 is nothing but 1, right? So 1 into u into nth derivative of v plus nc1 is n into the first derivative of u multiplied with n minus 1th derivative of v plus nc2 is nothing but n into n minus 1 by 2 factorial, second derivative of u multiplied with n minus 2th derivative of v, so on. The last term is un, nth derivative of u multiplied with v. Just make a note of it, students. In order to find the nth derivative of the product of the two functions, choose your u in such a way that its derivative terminates after certain stage. That means choose your u so that its derivative becomes 0 after a certain stage. Okay, this is a very important note to find the nth derivatives of the product of the two functions. Now just substitute n is equal to 1 in the above formula, students, so that the above formula reduces to the form the first derivative of u into v is equal to u into the first derivative of v plus u, the first derivative of u multiplied with v. This is what you have studied by the name product rule in your PU, isn't it? So I can say that the nth derivative, the Leibniz rule for the nth derivative is a generalized rule to find the differentiation of the product of the two functions of higher order. Okay, so just make a note of it. We will just analyze the Leibniz rule with an example. That is, to find the nth derivative of the equation y is equal to e to the power 2x into 1 minus x square. From the Leibniz rule, the nth derivative of the product of the two functions u and v is given by nc0 u into nth derivative of v plus nc1, the first derivative of u multiplied with n minus 1th derivative of v, so on. So the last term of the expansion is ncn, nth derivative of u multiplied with v. But the most important thing in the Leibniz rule is you need to choose your u in such a way that its derivative becomes 0 after certain stage, isn't it? Since the given question or the given equation is a product of exponential and an algebraic function, so obviously we can choose the function u as 1 minus x square over here, because the third and higher order derivatives of 1 minus x square is 0, isn't it? So it is enough if I just consider the first three terms of the expansion, so that the higher order derivative or the nth order derivative of the product of the two function e to the power 2x into 1 minus x square is, let me just write the constant coefficients. nc0 is 1, nc1 is n, and nc2 is n into n minus 1 by 2 factorial. Let me just write u then. What is your u over here? U is 1 minus x square. u1 is nothing but differentiation of 1 minus x square. What is the derivative of 1 minus x square? It is minus 2x. u2, that is nothing but differentiation of u1. What is the derivative of minus 2x? It is minus 2. Then Vn is nothing but, what is your v over here? V is an exponential function, right? E to the power 2x, and we know that the nth derivative of the standard function e to the power ax is of the form a to the power n into e to the power ax. So what is your a over here? A is 2, isn't it? So to find the nth derivative of v is nothing but find the nth derivative of e to the power 2x, which is nothing but 2 to the power n into e to the power 2x. I am just replacing a by 2 over here. To get the n minus 1th derivative of v, replace your n by n minus 1. So what is that? 2 to the power n minus 1 into e to the power 2x. To get n minus 2th derivative of v, replace your n by n minus 2. So that is nothing but 2 to the power n minus 2 into e to the power 2x. So this is the nth derivative of the given function, given product of the two function e to the power 2x into 1 minus x square. If you want, you can simplify, or else you can live at this point itself. Let me consider the next problem, that is to find again the nth derivative of the product of the two functions using the Leibniz rule itself. Over here the equation is e to the power 2x into log of 3x plus 1. Just make a note of it, students. Over here the derivative of neither the exponential function nor the logarithmic function terminates to 0, isn't it, after a certain stage. So it's immaterial that any of the function can be chosen as u. For simplicity, let me choose u as e to the power 2x over here and find the corresponding nth derivative of it. From the Leibniz rule, the nth derivative of the product of the two functions u and v is given by u into nth derivative of v plus n into the first derivative of u multiplied with n minus 1th derivative of v, so on up to nth derivative of u multiplied with v. Okay. Over here I have chosen u as e to the power 2x and v as log of 3x plus 1. So first let me write the constant coefficients over here. The first constant coefficient is 1 and the second constant coefficient is n. Third constant coefficient is n into n minus 1 by 2 factorial and the last constant coefficient is again 1. Okay. Then the first term u, what is your u you have chosen over here? It is e to the power 2x, right? So write e to the power 2x. u1 is nothing but differentiation of e to the power 2x, that is nothing but 2 into e to the power 2x, okay, plus u2. What is your u2? That means differentiation of u1. What is the derivative of 2 into e to the power 2x? That is nothing but 2 square into e to the power 2x, and to get the nth derivative of e to the power 2x, we'll use the standard equation. What is the nth derivative of e to the power ax? The nth derivative of e to the power ax is a to the power n multiplied with e to the power ax, right? So I can say that the nth derivative of e to the power 2x is 2 to the power n multiplied with e to the power 2x. Okay. Next, let me find the nth derivative of v. What is the nth derivative of v? What is the v you have chosen here? V is log of 3x plus 1, right? Let me just compare it with the standard function log of ax plus b. What is the nth derivative of log of ax plus b? It is minus 1 to the power n minus 1 multiplied with n minus 1 factorial into a to the power n, that is the coefficient of x over here. Okay, a to the power n divided by ax plus b to the power n. What is your a over here? A is 3 and b is 1. So what is the corresponding nth derivative of log of 3x plus 1? Just using the above formula. Okay, Vn is nothing but minus 1 to the power n minus 1 into n minus 1 factorial. The coefficient of x, what is the coefficient of x here? It is 3. So it is 3 to the power n divided by 3x plus 1 to the power n. So that completes the first term of the expansion here. Now to get n minus 1th derivative of v, okay, just replace n by n minus 1 in vn to get n minus 1th derivative of v. So just replacing n by n minus 1 in vn. So the term reduces to the form minus 1 to the power n minus 2 into n minus 2 factorial 3 to the power n minus 1 divided by 3x plus 1 to the power n minus 1. Okay, this is the corresponding n minus 1th derivative of v. Now to get n minus 2th derivative of v, it is enough if you just replace your n by n minus 2 over here. So the term is of the form minus 1 to the power n minus 3 into n minus 3 factorial multiplied with 3 to the power n minus 2 divided by 3x plus 1 to the power n minus 2. And the last term of the expansion is v itself. So what is that v you have chosen? V is log of 3x plus 1. That completes the problem over here. If you want, you can simplify the terms by cancelling 2 and all. But even if you leave at this point, it is fine. Okay. Also, it completes the introduction part of the module 1, students. From this introduction part, it is enough if you just know the nth derivatives of the standard function and to find the nth derivative of the product of the two functions using the Leibniz rule. Thank you.